Hello, welcome to another video on gPROMS. Today we want to look at how to solve a second order ordinary differential equation in gPROMS. So if you have this kind of equation, so d squared x dt squared plus c over m dx dt minus g equals 0. So you have these parameters, c equals 12.5 kilograms per second, g equals 9.81 meters per second, and m equals 70 kilograms. So you have the initial condition as that. So at time t equals 0, x equals 0. So how do you implement this in gPROMS? So let's go to gPROMS and try to solve this. So I've opened gPROMS and I've created the model already in gPROMS. So I have the variable type created, has no type for the variable. Then I have the model. I open the model. So I already defined the parameter. So G as real. So I give a default value of 9.81. So you can do this as well. M as real, C as real. Then I defined the variable. So this is a variable in the equation. So the way you solve the second order differential equation in gPROMS is that you cannot define second order derivative directly. So you can't do like $sign twice. No, that's not how it is done. So what you need to do is to define a new variable, so which is the first derivative of that variable. So basically, you need x dot. So first derivative of that variable. Then you can then do $sign of that first derivative. So in order to get second derivative. So what I've done is to define a new variable. I call it x dot, which is the second derivative, which is the first derivative of that. And then I do like, if I do the first derivative of the original variable, I get the variable that I define as x dot. Then if I do, then the derivative of that will give me the second derivative of that. So basically, so in the equation, I have d squared x dt squared, which is this part, plus c over m dx dt, which is first derivative of x, minus g equals 0. So that's how you write the equation. Basically, you cannot do the second derivative directly on that variable. You need to define a new variable, which will be set as the first derivative of the original variable. And then you take the derivative of that in order to get the second derivative. Okay, so in the process, I created an instance of the model. I call it my model, and then I specified the parameter C as that and the mass as that. I already specified G here in the model. So then the initial condition at x equals 0, at time t equals 0, x is 0, then definitely x dot will be 0 as well. Then I decide to run for 20 seconds. Okay, so if I run this, what do I get? Then reporting interval 1, I'll keep it as it is. Then I run it. So run it, I have the solution case file. We expand that, result trajectory, my model variable. Then if I double click on the variable x that I have in the equation, then I have the profile. So this is how the variable looks like. This is the solution of that model. I hope this is useful. So if you find it helpful, please like the video and give it a thumbs up. And don't forget to subscribe to this channel if you are new to this channel. Thank you very much for watching, and I will see you in the next video. Bye-bye.